Now let us consider the interference of two similar waves moving in opposite directions. The resultant pattern is called a standing wave. This is because the patterns do not shift in any direction. That is, they do not move left or right. Though the particles constituting a standing wave are still performing SHM, like in case of a progressive wave, but the overall pattern remains stationary. Note that these points, where the particles do not move at all, are called the nodes of a standing wave, and these points, where the amplitude of the resultant wave is maximum, are called antinodes. Also note that, unlike a progressive wave, where the amplitude of oscillation of every particle is the same, in a standing wave, amplitude of oscillation of particles is not the same, but is a function of x. Let us represent these constituent waves by these equations. We can write the equation of the resultant pattern by applying the principle of superposition. On solving, we get this equation, which is the equation of a standing wave. This equation is of course not the equation of a traveling wave, because here x and t are not related like this. In this equation, if this term is equal to 0, then the displacement will be 0 at all times. That is, for any value of t. This happens when kx is equal to pi, 2 pi, 3 pi, etc. That is, when kx is equal to n pi. Writing k equal to 2 pi upon lambda and rearranging, we get the values of x where displacement is always 0. That is, the position of nodes on a standing wave. Note that the nodes are separated by half wavelengths, and in the middle of two nodes is an antinode. That is, for positions where this term has the maximum value. Using the maximum value of sine function, we can say that the maximum amplitude of the particle at an antinode is equal to double the amplitude of the constituent waves. And this happens at positions where kx is equal to pi by 2, 3 pi by 2, 5 pi by 2, etc. That is, for kx equal to 2n plus 1 into pi by 2. Solving this equation, we get the position of antinodes, which is expected are in the middle of nodes. Note that for any general value of x, this term represents the amplitude of oscillation of the particle located at a distance x. Therefore, this term gives the amplitude of the standing wave as a function of x, and this term represents the variation of this pattern with time.